عندي واحد مع الدايمنشن already. Okay, so you can get the dimensions from here. So for example, if we go from here to here, it's around 2.2. Okay, so this is the first line. Okay, so here we have a line, and then here we have a line, and then we have another one here. So what we can do, we can get this area. So I'm trying to calculate the N-rail area now. So we have 3600. Okay, so we got this one, okay, and then what we can do, we can get the other line, which is from here to here, as 4100. Okay, we can get this as well. Okay, so you try to get as many dimensions as you can, so it will help you in terms of drawing it. Okay, once again here. Okay, then lastly it's here. Okay, so we try to draw different, what you call, the different lines. Okay, the different lines, but once again you need to take into account the center to center, distance. Hmm? Huh? Here it's not mentioned, but if you measure it as 300. Okay. You cannot see. Okay. So we can have this one directly. Okay, but once again we need to measure from the center to the center dimensions, center to center dimension. Let me see the other. This one might be little bit easier since I have drawn already the grids. Okay, since I have already drawn the grids, what I have done, when I receive normally a CAD file. Okay, when I receive a CAD file, normally I draw the inner line, which is the center. Okay, and I keep copying it all over whenever, like for example, this wall now. Okay, so I'm just copying it. Let's say this is in feet, and okay, so I'm going to copy it in, let's say, half of the wall. That's 150, and then once again you keep copying it all over. Okay. Okay, so this appears for me to be, I think it's hard to see the red color. Right. What color? White. Everything will be in white. Still, let's move. Okay. And once again, I don't want to take a lot of time in terms of drawing. I just wanted to highlight if we have a drawing with different grids, what to do. So you try when you try to draw a robot or any structural project, try to take all the positioning of walls, because sometimes you will be having intermediate beam or a secondary beam in the middle. Drawing a secondary beam is going to be a little bit hard if you are not drawing the grid line from the beginning. Okay, so it's always better to know the lines from the beginning, and then accordingly to put the beams. So we have 2500 here. Okay, and then you can see that we have A, B, C, D, and then E and F. I try to have all of them, right? Okay, so in this case, automatically, either you can do whatever I have done, or we can directly take from A to B, that the distance here is 2500, and then enter once again to find the other distance. So we are talking about around 1400. Let me just make it a little bigger. Okay, so 2500, and then we have 1400, and then we can get the distance from C to D, D to E, and then E to F. Once again, the typical thing that we have done. Okay. So here is 500, and then here 2700. So these are representing the grids I'm going to. These are representing the grids that I need to draw. Okay. So most probably I'm going to give you this one to try. Okay. Rather than spending a lot of time once again in drawing. Okay. Anyhow, I'll just highlight because you need to have something. I think I have told you. You already know, but just to recap. Okay. And once again, since you have already drawn the lines, but what you can see from here, I try to cover all the walls, whether in the horizontal or on the vertical. Okay. Why? Now, grids are not a problem of being too many. Grids are not going to be shown in reality. Grids are there only for you, so you will be having easy job in terms of positioning of columns and positioning of beams. So if you are putting many grids, it does not mean that you are wrong. It means that you are trying to make your drawing easier. Okay. So that's why you can see I have, for a small plan, I have kept a lot of grids because I want my drawing later on to be a little bit easy. Okay. And then eventually whatever we have done, if you remember, we went and defined the grids. So 2500, 1400, 500, 2700, and we said we are going to use shell design. Okay. So here, this is representing your x. So now if we return to our drawing, it's 2500 means 2.5. Okay, so what we said we are going to fix this one. This is going to be repeated, and then this is going to be the distance, so 2.5. So we had our first distance, fixing the number of repetition, changing only the distance. So now the other distance is 1.4 meter. So going here 1.4 meter, and it goes on, right? And it goes on. The same for y. It's going to be in the other direction, and then z is height. Okay. Now let us see the file that we have done previously. And I'll do one thing so we can all recap everything. Normally I create one drive. Okay. Normally I create one drive so it can be accessed by everyone in the same training, and then all the files will be there. Okay. So I'll just create a new OneDrive for you. Okay. So even if a person has a mistake in his drawing, he can download the drawing which is available in that particular the folder rather than flash drive, copying, returning. Everything is going to be online only. Okay. It is hot, right? Hot, right? If you are feeling cold, let me know. So I just call it robot.intensive. So robot.intensive. This is the email, the new email I'm going to create for your OneDrive. All the documents related, all the trainings. Okay, all the trainings will be here. All the files will be there. When you finish from your own file, create a folder over there, and then post it so I can check it. Okay. So robot.intensive. Next. Okay, let us have a simple password. So this is going to be your password. Let me just zoom it. Hmm? Okay, so it's going to be robot123 exclamation mark. Are we okay? Okay. Now, do you have OneDrive in your phones? Can you check? Now, in each and every phone, there must be a OneDrive. If you require internet, I'll give you the Wi-Fi. Huh? The Wi-Fi name is Baraji, and this is a password. Name you cannot say. This is for the Wi-Fi. The Wi-Fi is called Barajil, and then this is a password. Okay. Now, after doing that, log in your OneDrive over there. In your OneDrive, log in using the email address and the password that I have given you. So I'll show you what's the benefit of using the OneDrive. Now, for me, if you ask me, I started nowadays stopping to use flash drives. And if you see, when I have installed for you and you, I have downloaded it from OneDrive. So all my applications, everything is available only in OneDrive. I can open it in my phone at any time. I can open it in the web at any time, and it's available in my computer at any time. The good thing about OneDrive, if you upload anything, within seconds it will come to you in your other devices. Okay. Are we fine? Hello? Have you done? Okay, now Can you see how many folders are available in your OneDrive? Nothing, right? Only there's personal file. Okay. I'm going to create a new folder. Okay, where we say training. Can you check that it's appearing for you? It will appear automatically. Okay. So training has appeared, doctor. Okay. And then I'll just have a folder for each one of you. I'm not sure of the spelling. No, give me the right one then. Eyes. Okay. Okay. And then we have. So I have created a folder for each and every one. Okay. Now all of your training, all of your things, keep it over there so I can verify whatever you have done. Okay. That will make it a little bit easy rather than going for email because sometimes the file is going to be huge. Now the last thing that we have done was related to this model. Have we completed it? Okay. Do you have it completed here? Have we done the slabs? We have finished this drawing the slab, right? Okay, so can you upload it? If you have already finished, can you upload it in your folder? I think this one. So 7. This one, right? Okay, so what I'm going to do, I'm going to save it in case if you don't have it over there. Training. So you can now download the file from training. Can you check in training? Can you open it on your computer? Can you open your OneDrive from your computer? Open using your account. Why I'm trying to do that? So we are going to apply the loading and everything in that model that we have created previously. Okay, and we'll see how to change columns, how to put some columns inside, going outside, as Arwa has asked. Now, in your model for the engineer, have you checked whether he is putting it center to center or huh? In his not in CAD, in the robot file. In CAD and Revit, it's always going to be in the correct position, always. But in the structural software, 99% of the engineers will keep it center to center. Did you ask him for the robot? عادي سألي بالعربي. قولي له ارسل لي سامبل من الملف مالك. انتوا الملفات ما تخليونا استشاري في المكتب. Huh? Okay. But you can download from Dropbox. هي عندك. زين عادي خبري أحمد. قولي له أريد أنزل سامبل من اللي from whatever has been done in Robo. Okay, and I'm assuming that he is doing a center to center, and in both scenarios, I'm going to explain for you. Whatever we were saying, Dr. Ihtisha, that normally in CAD and Revit, we are doing positioning of the columns. Columns are rectangular. Now, in most of the cases, if you transfer them to structural software, it will be only linked as center to center. Most of the software, okay. And most of the engineers are keeping them as it is. They will not change the what you call the positioning. So they are assuming that the column is having full actually loaded case, which is, let's say, the worst scenario. Okay. Huh? Okay. Okay. Got it. Let me try. Okay. I don't want you to save it in IFC. Then you will be having a problem. Now, if you are having a higher version, what shall you do? You cannot lower it. That's the biggest issue. Okay, I'll show you. I think you are having all of you 2020, right? All of you are 2020. So what I'm going to do now, the only way to do it, okay, the only way to do it is to export it as IFC. Okay, so just I'm opening, I'll upload the IFC file, and then we are going to see what will happen. Once again, IFC is having some drawbacks, so we are going to save as even IFC is not here. Now, when you have worked, it was 2020, right? Okay, can you upload your 2025? Huh? You uploaded in your folder. Let's download it from there. If it's higher version, IFC and Revit. Okay, and Robot you can uh, try to save it as text file. Okay, and then open the text file in the lower version. Okay, but always, if you are working in one software a lot, like if you see now in my case, I have, since I'm using Robot a lot, you can see that I have four software of Robot. Okay. So I'm having 17, 19, 20, and 21. So I'll not have an issue of file not opening for me. Okay. They don't take a lot of space normally, but it's going to be better if you are practicing in practice. If you're doing a professional job, it's better to have more than one version, so you will not have a problem of upgrading, downgrading, issue of opening it in lower version, upper version. Did you download it? Okay. So I'm going to work directly on the what you call them on 2021. Okay. Now what we want to do, we have what you call, we have checked everything. Now the first thing I want to change the column sizing, because the easiest sizing was the square. Okay, so what we want to do, first I'm going to go for new column. Can you click on the new column button, new column here at the right side? Let me just try to make the screen big a little bit. the column from here. Always when you are trying to have a new section, first you need to define it. Okay, so we went for the column size. Let us say that our, of course it's an RC, and then we are going to, let's say, 200 into 500. Okay, 200 into 500. So grade of concrete, I'm keeping it C35 for example, and then I'm keeping here 200 to 500. Make sure that the units are in mm. Here. Everyone having the units of mm. Okay, so we are adding, and then we close. Okay, so what did I do? I have defined the new section. Okay, I have defined the new section. Now what I'm going to do, on your left side there is the inspector. Have you seen the inspector on the left side? Okay, can you go to the column? How many columns are there? 12. Right click on them, select all. You will see that columns has been selected. Okay, at the bottom you can see that the section is 215 to 250. Can you see? Can we change it to the new defined section, which is 200 into 500 that we have done? BR is for beam, CR is for the column. B is for beam, C. I have a lot of defined sections that I have defined previously. Now, once again, when you define it, if you are using 2021, for example, I have defined a section previously. The section will be there. You don't need to redefine it each and every project time. Okay, so 200 and 500. Now you will see, whenever I click, you will see that the columns has changed. Okay. Okay. Now what I want to do. Okay. Now what I want to do. I want first to rotate some of the columns. Okay, I want to rotate some of the columns, okay, because not all of them are going to be of the same orientation. Okay, so for example, I'm going to rotate uh, this column and this column. Okay, these columns are going to be rotated in the other direction. So what we need to do, I'm just going to click on this one, control, use the control, the bottom one, the other bottom. Are we fine? Okay, fine. Okay. Normally, on what basis you are going to decide the orientation? Depending on the size of the spans or the beams. Now you can see the beam here on this side is bigger than the beam on the other side, so it's better to keep the column oriented to the longer side. Okay, okay. But just for the sample here, for example, the positioning is fine because these are going to go for the longer direction. Okay. I'll just change two of them and we'll see what will happen. Now, in the inspector as well, when you go and see, can you tell me what's gamma? There is gamma. Have you seen what's gamma? Zero. It says 0 degrees, right? You cannot change it. Can you click on the plus sign? There is a plus sign. And then can you write now it is going to be 90 degrees? And then enter. And can you see now it has been rotated? Okay. So have you seen how to rotate? How to rotate? Okay. You can put any angle. For example, 45. It will be 45. 90 to be 90, 180 to be 180 is the same as 0. Okay, so for example I want it to be 90 now. Okay, so this is whatever we have learned. Now we have learned how to rotate the column whenever we require. Okay, the second thing is how to put the column inside, because previously we didn't have an issue because the column was square, so it was always inside the wall. Now in this scenario it is not. If I shift, you will see that my column, okay, you will see that my column is acting on, I mean, in a portion which is outside. Okay, okay, which is here. Okay, which is here. So what I'm going to do, for example, I'm going to pick this column. Okay, I'm going to pick this column. So I have picked the column and picked the column beneath it. Are we fine? Okay, so once again we pick these columns. We need to move them. we need to move them, so we'll go for edit, edit, and then move. Okay, now we need to understand these things. We have dx, dy, and then we have dz. X is a movement in x, movement in y, and movement in z. We don't want to move it in z, of course, because z is height. It's either x or y. Now for me, if you see, if I click on the top view, I want to bring it in this direction, okay, which is the direction of y. Can you see? It's not the horizontal x direction, it's the direction of y. So my x is going to be 0, and then this, they are separating for you dx from dy from dz by comma, right? So 0 and then comma. Dy is how much? Okay. Now if you see, our column is 500, right? Okay, our column is 500. Okay, our column is 500. So 500, and the beam size is 300. Okay, so let us try first point 2. Point 2, is it going to take you on this side or this side, on the upper side or lower side? Now you can see the y. Can you see the y? Positive is going to the upper side. You want to return it to the lower side, right? So it should be in minus, so we are going to go for minus, and then 0, and then can you click on move and then execute? Now can you see one of them has shifted? Can you see one of them has shifted? Now it's always, if you ask me, it's always going to be better for you to draw one flow columns and then copy them later on. Now why this is happening? Because these columns are actually connected to each other. Okay, so you are trying to pull one of them while keeping the other one in the same position, because the other one is linked to a foundation as well. Okay, so you are trying to fix a foundation, you are trying to pull the first one. Okay, so it's always better, if you ask me, it's always going to be better for you to draw the columns of one level and then copy the other levels as whatever we have done previously. Okay, so modify the orientation, accordingly. Now can you see here, can you see in your plan how the column now has shifted? Oh, have you seen? There is another way which is somehow, for me, little bit simpler for me, and as a person, as I'm using different softwares, and I think I have showed you, Alvin, right? So you can export this one to Revit. Okay, you can export it in Revit, modifying it in Revit, and then bringing it. Modifying it in Revit for the column is a little bit easier. Okay, so for example, you just see here, I'm not sure whether you have Revit the same. I think you have Revit 2020, I believe. Okay, okay, so can we go for integration? There is add-ins over there, add-ins, can you see? And then integration. Can you see Revit, Autodesk Revit structure? Have you seen it? Okay, now first thing, if you are transferring to Revit from Robot, you need to open Revit, you need to keep it open. If you are transferring from Revit to Robot, you don't need to open Robot. Okay, it will be opened automatically. But for Revit, because we have different templates, it's not only one template. It's imperial, it's mechanical, electrical, so we need to pick the correct one. So what I'm going to do, I'm going to go for Revit. You just see what I'm trying to do. Do you have Revit with you in the computer? You have 2020. Okay. Now for you, it will not take a lot of time to open somehow. For me, because it's linked with Procon, so it requires to check the license of Procon each and every time. See, that's why Procon is coming. Okay. Now, did it open for you? Did you get this one? Everyone? This is not necessary because this is my own work now. It will not appear for you because you are using a different system. Now, when you click on new here, when you click on new, you will see whatever appears for you is different from whatever you are seeing with me. Once again, we are going to new, open. Okay. For you, when you click on new, you will see that you have, I think, few options, right? Okay. And all of the options for you are imperial, although it's not written, but it's imperial. Now, the difference between 2021 and 2020, in 2021, at the interface, it will give you both options, metric, imperial, from the first, what do you call it? From the first window. Now, for your case, what you need to do, you need to go and browse. You need to go and browse. Have you browsed? Okay. Over here, you can see that there is English imperial. Yours is imperial. Yeah, or US. US imperial, right? US imperial, English imperial are the same. So for you, you need to go to templates. You need to go to templates. From templates, you can see over there, for you it's easier. Here I have installed a lot of templates. For you, you can see metric. Can you see metric? Now in metric, when you click on metric, there are different templates inside metric, right? Different ones. Can you search for structural analysis? There is one which is called structural analysis default. Have you seen it? No, default metric. Structural analysis default metric. If you are using 2021, then it's direct from here. Okay. So I'm just clicking. Now Revit will be opening. Default structural analysis metric. It does not matter. They don't have a lot of change. I mean, a lot of differences. Okay, but pick the default one. Now Revit has been opened. Okay, Revit has been opened. What I want to do, I'll go on robot. But go and open your robot, and then from robot go to tools. Oh, sorry, not tools. Add-ins. In add-ins, go to integration. In integration, you have Autodesk Revit structure. Have you seen it? Click on it. Now, can you see here we have different options? We have send model and results. We have update model, direct integration, send to intermediate file. Can you see? Now, if you are sending from Revit to robot or from robot to Revit, if you are opening now, I'm opening what you call, I'm opening robot and I'm trying to send it to Revit, so it should be sent. Okay, I'm sending from the first one to the second one. Okay, now if you have done the analysis and you want also to send the analysis results to Revit, you need to go for send model and results. Okay, if you want only to send the model without the bending moment and the shear and whatever, it's only send. The file is going to be a little bit light. Okay, send model and results. You can see that it's not applicable to go to intermediate file. We have direct integration and intermediate file. If you are from the same company, the integration is direct. Revit robot are direct. If for example you are trying to transfer from robot to ETABS, for example, you need to have an intermediate file. Okay, so update model is whenever you have done, okay, you have already sent to Revit, you have modified some of the things in the robot and you want these modifications to be reflected in Revit. So you don't need to send it once again, you need to only update the model. Now for us, we didn't send it previously, so we are going to use send model. Okay, so once again, if you send for the first time, it's send. If you have sent already but you modified something, it's going to be update. So we are sending the model and clicking on OK. One of the things to be taken into account, you need to have uh, the same versions. You need to have the same versions for the what you call it, for the transfer. Now you will see that a command completed successfully. Okay. Can you click close? Go to the Revit, and then can you go to the home button here? Can you go to the home button, and can you see that your model has came for you? Did you get your model? Home button at the top. There is a home button which is a 3D. Have you seen it? Arrow. Okay. Now you can see it looks like something which is not clear. Okay, or what you call, the type of material is not shown as well. So what you can do, at the bottom here, at the bottom, there is something called visual style. Here, bottom. Okay. There is visual style. Have you seen it? And then can you go for realistic? So now you will be able to see where is the slab as well. Previously it was not clear. Are you able to see? Okay. Now if you see here, what happens? For example, this column. Okay. Can you see that this column is going outside? This column is going outside. Okay. Arwa. Samod. So what we want to do now, we want to modify this column's position. Okay, I'll show you how to modify in Revit. We are not going to change a lot of them. Okay, you can practice that yourself. So we'll start the analysis. Okay. Now, if you can see here, what you can do, it's always going to be better for you to work on a plan. Okay. Now, before working on a plan, I need to check whether my levels are correct or not. Okay, so we will go for elevation. Can you go for the elevation here? Can you go for either elevation? Okay, you can pick any of the any elevation. Okay, you can pick any of the elevations. Can you see now what are the heights you are having? Okay, once again, here you'll find elevation. Have you seen? You can pick any of the elevations. Okay, you can see it on the right side because by default it's the left side, but some of them are taking it to the right side. Okay. Now can you see in your drawing that one of the column has been rotated here? Like for example, can you see the orientation of the column are not the same? Okay. Now the most important thing for me, you can see that we have minus 1.1500, we have 0, we have 3000. Now 3000 is not there. In the initial one, it was minus 1.5, 0, and 3.5. Okay. So level number 2, I don't require it. So we can go and delete. Okay, we can go and delete level number 2 because we don't have anything laying or sitting on level number 2. So we deleted it. If you are deleting story number 2, you will see that everything in level number 2 will go. So be careful which one to remove, but you can use Control Z if there is any problem. Okay, now we can delete it using the keyboard. Just highlight it and then keyboard, and then okay. Okay, okay. Now we can name, so we will have like easier job. So the bottom one, for example, the bottom one, I'm just double clicking here. I'm just naming it to be foundations. Okay, you can name it whatever you want, but for the sake of, I mean, easier verification, it's better to use your own naming. Now it's always better as well. It's always better as well that these are going to be of the same length. Why? Because if they are of the same length, you can move all together. Can you see here what's happening? Once again, just concentrate here. See, previously what happens? Two of them are in the same line, one is not in the same line. Okay. Now, if I move this one, it will move separately. So for me, always it's better to connect them together so you can move them together. Okay, so what I'm going to do, I'm going to pull it till it shows you that you are connected to the other thing. Have you seen? Now, if I move any one of the three will move. Is it clear? Okay. Now, can we call this one story one? Can we call it GF? That's ground floor. And then the other one, let's call it as first floor. Okay. Are we okay? It's not hard, it's easy. Okay, the only thing, sometimes it appears here for you that these are in black color. Okay, now what is the color of these levels? They have been represented in blue color, right? If it's black color, it means that floor is not active. I'll show you. So for example, let us say that I'm having this one. I went for copy, and then I created a new, for example, a new floor here. Okay, you can see that this is now in black color. Black color means it's not active. What does it mean? It means when I go and check for the plans, I'll not see GG. You will see ground floor, you will see the foundation, you will see the first floor, but you cannot see the GG. Now to see it, what you need to do, you need to go to view. We are talking about what exactly? We are not talking about 3D view, we are not talking about section, we are talking about a plan view. We want GG plan. So we'll go for structural plan because we are working on a structural template, and you can see GG is the only one not active. If we click here, you will see that GG is going to be turning in blue, and then GG is available here now. Are we clear how to what you call to activate it? Now we don't require it. I just deleted it. Are we fine? Okay. Now why I'm doing like this? Because previously the plans were not shown to you. Okay, the plans were not shown to you. Now it's very easy for me to go, for example, for a level. Let's say I'm going for a first floor. Okay, when you go for a first floor, you will see your plan. Now, can you see that the columns are going outside? Can you see that the columns are going outside? Okay, so what we can do, I can go and pick this one, pick a column. I have picked a column, okay, and you can start moving it. Okay, so you can write M directly in the keyboard. What that's cat here, and then you can use move or MV here. I think M in CAD, right? M in CAD. So for Revit, it's MV. So move. I want this end of the column to be the end of the beam. So what I'm going to do, just see here, I'm going to pick this point to this point. Can you see what happened? Are we fine? Okay, now this is in first floor. If I go for ground floor, you will see that you can see now what happened. Once again, see the first floor. My column is in the correct position now. Right, this is my column. Can you see that? Can you verify that it's the correct position? Now, if I go for the ground floor, it will tell me that you are having two columns which are not in the same, in the same level, because we moved only one, the other one is not moved. If I want to see it in 3D, see how it's happening. Can you see what's happening here? That one has been moved, the other one didn't move. Have you seen it? Now, in some of the structural projects here, we don't have similar cross section all over from the beginning till the end. At the bottom, we are having the same, and then we are going to reduce. So you can use this function. Although 99% we are using uniform section to avoid any practical or labor issues. Okay. So once again, how we are going to modify? We'll go for ground floor. I'm going to shift this column to the new position. Now, if I go to the 3D, you'll see that both of them are the same layout. Are we fine? Okay. Is it clear now? Okay. The other thing, now if a person told me like I want to do the rotation not in Robo, I want to do the rotation of the column or orientation of the column in Revit. Okay, so you can do the modeling in Robot. It's easier in terms of accuracy. Okay. Now, if you model the slabs in Revit, they are not going to be fully 100% correct when you transfer to any other software, even if it's Robot. Okay, so normally I recommend if the structure is easy, you draw everything in Robot. If the structure is complicated, draw the beams and columns in Revit, send it to Robot, draw the slabs in Robot. Okay, if it's complicated, Revit is not going to generate for you accurate slabs. Okay, and then you will have to modify them once again in Robot. So it's better to work the slabs over there. Okay, anyhow, I want to rotate. So what I'm going to do, for example, I'm picking first floor. Okay, let us say that I want to modify this column. I want to rotate it. Okay, I want to rotate this column. Okay, so what I'm going to do, there is a rotation here. Can you see? RO rotation. Okay, so we are clicking on the rotation. It will tell you what is the axis that you are picking, and this axis will be rotated to which axis. So what I'm trying to say I'm going to pick this line, and then I'm going to take this line to the side. Can you see what happens? Okay. Now I want to move. Is it possible to move? We'll go for move, picking the edge of the column to be the edge of the beam. Are we fine? It's easy, it's not complicated. Yeah, because the beam is here, right? Once again, see the column is outside. I don't want it to go outside. Okay, so I'm just taking this one here, moving it from this position, the edge of the column, to go out to the edge of the wall or the beam. Okay, are we fine? Now if you go to 3D, because we rotated one of them and we kept the other not rotated, can you see what's happening here? Where is that crazy one? Can you see here? Can you see that one is rotated, the other one is not rotated? Okay, so in Revit you can play a lot, okay, in terms of orientation and everything. Now if you have finished and you want to transfer it once again back to Robot, okay, what you need to do, once again you need to go to Analyze. If I want now to send it from Revit to Robot, I'll go for Analyze. Okay, so Analyze, there is a structural analysis link. Have you seen? Click on it, and then you will see Robot structural analysis link. Okay, and then doing that, it will send, now it will send from Revit to Robot. Okay, is it clear? Okay, now let us try to, let us try to send the model. It's always better if you are having an existing one. If you are having an existing Robot file and then you transfer it, it's better to open new file. Otherwise sometimes they are mixing. Okay, now can you see what has happened? This was like this change we didn't do, right? Do you remember that this change we didn't do in Robot, we have done it in Robot? Do you remember? Now, do you remember when I told you about the linking? Now, can you see what has happened? That the software is trying to link it center to center always. So once again, okay. If you are going from Revit to Robot, it will link, or from Revit to any other software, it will always link you center to center only. Okay, so it's better to modify the columns in terms of positioning it inside and outside in Robot. In orientation, it's easier in Revit. But so it depends on how would you work. But once again, you can see here that this is the center of the column. Now the column has been shifted, so it has been drawn to here. But what you can do, for example, I can pick this line now, okay, and I can move, okay, I can move this point to here. Have you seen? Have you seen what I have done? But eventually, have you seen what I have done? Okay, so Control Z. Can you see this beam? There is a point here. This is a point of intersection. Now I want to pull this point. Click on it first time. You will see that it's coming in green color. And then I'm pulling it, taking it from here to here. Can you see? It's not coming. Once again. Click here. I'm just, first thing, I'm just clicking on the point. It turns green. And then click on the point once again. Pull it. Okay. Uh, Click on the point. Pull it from here to here. And then point. Okay. But eventually you need once again to do the, you need to do the, but not the orientation, but the eccentricity. Now see over here what happens. This is, this is the correct, somehow this is the correct one, the red one. Can you see? Because now what you try to do, this column is still going outside. Okay. So once again, you can do what you can do. The easiest job is to go and do it using move, the move that we have done in robot, or you can use Tekla. Using a lot of software, you will be having what you call big issue. Okay. And most of you are not having. Anyhow, I'll try to make for you, rather than taking a lot of time, I'll try to make for you the possible ways for you to shift in a video, the possible ways to move column. There are 3 4 methods. Okay. So I'll just try to do a video and I'll upload it in your OneDrive. Okay, so you can verify. Okay, but the easiest, the most accurate thing is to work with Android. Okay, and once again, this is the thing why most of the people, I think yesterday I have showed, before yesterday I showed you a plan, right? Did I show you a plan of ETABS last time? Last time? No, I didn't show you. Scheduling. I showed you. Yeah, yeah. No. Did I show you 200, 700? No? Okay, I'll show you later. Yeah, I showed you. Okay. I think I showed you. Okay. Maybe. Okay. Anyhow, let me just show you once again now. Mm, Structural calculation, did I show you? No. The sample. No. Yes. I don't remember. Okay. Okay. In the sample, I have shown you. I have showed you the what you call the the drawing, if you remember, from ETABS, the plan in ETABS, and how the columns are taken, or how the linkage has happened from center to center. Yes. This one, right? No, this is a flat slab. Okay, till that opens. Anyhow, so now what we have learned how to modify the orientation in Revit and Robot. We have learned how to shift the columns in Revit and Robot. Okay, the actual thing that we need to do is going and design. Okay, so we'll return back to yeah, I think I have showed you this. No, it's not the other one there. Not here. Okay. Okay, so what we try to do now, we'll try to be uniform. Okay, we'll try to be uniform because we have played a lot with the with our file. So you can go and Control Z to return it back as it was. Okay. So now I want to put the loading. I just Control Z to avoid the playing that we have done. Okay. Although you can continue with it, just ensure that your columns are having the same orientation, the bottom one and the top one. Okay. Now the next step. Okay, the next step. Okay, just concentrate here with me. The next step is to define and apply the loads. Okay, so what we need to do, can you see here that there is an icon for loading on the right side? On the right side, there is something called load type. Have you seen it? Can you click on it? How, m- how many things do you see here in your window? How many? Nothing, right? Nothing, everyone? Nothing? Okay. Now, can you remove the section shape? There is L here. Do you remember the section shape? Can you just click? Okay. Now, what I want you to do, the first one, can you call it as the SW? Can we call it as SW? And I'll show you why I told you to remove the section shape. Okay, SW, and click on Add. Can you see that the structure became in red? Okay, it means that this one is representing your self weight. Okay, so the software is going to be automatically calculating your self weight. You don't need to calculate it. Are we okay? Now the second one, you have nature here. Can you see the nature? Life, wind, snow, temperature, accidents, seismic. Can you see them? Okay, now let us go for that and let us keep it as finish. Now if you want further, you can go for roof finish. If you remember, we discussed the roof and floor finishes. We said they are different in whatever. So you can, for example, go and define floor finish as new one. Now if you add it, you will see that the red color is going to go. It means that in the second one, self weight is not calculated anymore. Self weight will be calculated only once, right? It will not be calculated in each and every time. Okay, so floor finish, for example, the other one is going to be roof finishes, right? Okay, other than that, for example, we might be having sunk load for the sunken slab, right? So you can add as many loads as you require. Are we clear? Okay, so for example, we are going to go for water tank. water tank. We want to go for example AC, then it's AC. Are we fine? Other than that we have a life load. Okay, so we are going to change the nature. We are changing the nature to life load, and we'll call it life. Okay, are we okay? Naming is not a big issue. You can name it whatever you want. The only important thing that you need to make sure that the natures are chosen correctly, because the natures will be taken into account for the calculation of factor of safety 1.4 and 1.6 and whatever. Are we fine? Okay. Now what did we do? We defined that these are our loads. We didn't define how much are they. Okay. So I'm just going to close. Or before closing, I can go for that and then I'll just write wool. Okay. Okay. Have we done the wool? And then another one. Let's say parabet. Some of the designers will keep wools and parabets together. Okay. That's up to the person. Some of them are going to have something called SDL, super dead load, which is AC and tank together. Different naming, but the concept is the same. Okay. So I have added and then close. Are we fine? Okay. Now you can see these are coming here. Can you see them? Can you see that these are coming here? Okay. SW, floor finish, roof finish, sunk load, water tank, AC, live, hole, whatever you wrote, you will find it. Okay. Now what I want, now for example, I want to load, of course, live load and dead load will go to the slabs, except for the wall load, will go for the beams. So what I want to do, okay, first save, just ensure if there is anything goes wrong, you have done loading wrongly or something before it crash, and then you need to redo it. Okay, so I just saved it. We'll go and choose the floors, select all floors. I have selected all the floors together. Once again, right click on the floors. You don't see it, it's not there, it is there. Okay, so right click, you can see that it has been highlighted now. Okay, it has been highlighted. What we can do now, can you see that the other loading here, the other load icon has been activated? Previously it was not activated, right? So after you define the type of load, you define its value. Okay, you cannot define something value unless you define what it is first. Okay, so can we click on the second icon, which is load definition? Okay, now it will tell you, are you talking about Barabit? Can you see the case number? Barabit. You can see that Barabit is here as well. Can we change from the top? Can we keep it, for example, number 8? Can you see that this is changing automatically? Okay. So for me, for example, I want to have the live load. So we'll go for the live load. Live. You can see that it has been changed to live. We have four options: self weight and mass. So accidentally, if you have deleted the self weight and you want to put it once again, you need to use self weight. Okay, you need to use self weight and mass if you deleted it by mistake. Okay, and you can choose all the structure. So once again, the software is going to calculate the self weight for you. Other than that, we have node. Means, do you want your loading to be a point load, or do you want it to be a bar, which is a line, or do you want it to be a surface, which is area? Are you loading a line, or are you loading a point, or are you loading an area? Slab is an area, beam is a line, column is a point. Now, which element we have specified? We have specified slabs, right? So it's going to be surface. We have different types of loading. The first one, you can see that the loading is all over the slab. Can you see? Second one is partial or in certain area. And we don't want that. The loading is all over, right? So go for the first one. Now we have X, Y, and Z. We said X and Y, if you see here, which one is vertical, which ones are horizontal from the axes that you have here. Can you see the axes? X-axis, is it horizontal or vertical? From the coordinates, can you see the coordinates? Coordinates, X is horizontal, Y is horizontal, Z is vertical. Loading is going to come vertical or horizontal? Vertical. So you cannot put in X, you cannot put in Y, you can put in Z. Now, one thing before you put your loading in Z, your Z positive goes where? Up or down? According to the coordinate, it goes up. Your loading is going up or down? Down. So it should be minus. So minus, for example, minus, let's say minus 2. Are we clear? I'll just add. By default, these have been already selected, we pre-selected them, right, from the beginning. Okay, so I'll just click apply. Can you see now loading came on the slab? No? Okay, nothing has been shown? Huh? Dotted line. Okay, no problem. Can you check the value? There is 1, 2, 3 here. Can you see the bottom ones? Can you see 1, 2, 3? And can you check the value of the loading? And how much is it? Now, if you are closing, you will see that the load is hidden. Okay, how to find it? Now, here over there, you can see there are two icons. There is one which is showing a loading. There is another one which is showing 1, 2, 3. Can you see? One, two, three is showing you the value of the loading. The second one is showing you the loading level. Okay. It means that it's not deleted, but it's hidden now. Rather than having, because if you are having a big project, loading will disturb you if they are shown. Now we have finished from the live load. We want to go and put dead load. So once again we are going to go here. For example, I want to go for roof finish. Roof finish. You will see by default this has changed, right? Here it has been changed, roof finish. Can we go for uniform plan? UDA. Now can we put, for example, minus 1.5, for example? Okay. Once again, the finishes are depending on the specification, what type of finishes you are having in that particular building. Okay. Which is normally given by, or each company is having its own. That's why I don't want to give you a value and then your company is going to use a different value depending on the materials used. So it's better for you. I have showed you, I think, the typical value last time, huh? In the structural calculation. I'll attach the one of the samples of structural calculation in the OneDrive so you can refer to it. Okay. So minus 1.5, click on add and then apply. You can see the new loading came. Are we okay? Now can we check the previous loading, whether it's there or not? Can we change from here? Can we check live? Can you see that it's available or not? Okay. So it's available as 2. And then this is available roof finish as 1.5. Are we fine? Okay. Now let us say that we have finished from uh, we have finished from the slabs. Although there are other loads, but I don't want to spend a lot of time in each and every load. But now the second thing is going to go to the wall, because the concept is different. AC, water tank, all of them are going to come in a slab. So they are going to see, I mean, they are going to have the same concept of life and death, but walls is line. So we need to see how to do it. Okay, so what I'm going to do now, if you see in terms of wall, we have two types. One is wall, one is parapet. Okay, because parapet is going to have, why I separated them, because parapet is going to have a lesser load, because normally they are 1 meter or 1.2 meter, while the regular wall is going to be for the whole height, right? So there is a difference in terms of loading. So what I want to do now, first, can you make sure that you have how many levels? Do you remember the leveling that we have done? Can you click here? Can you click here and check that you have two stories? The base is available at which level? Minus 1.5. Story number 1, 0. Story number 2, 3.5. Are we okay? Now what I want to do, I'll go from here. I'll tell the software to choose story number 1. Did we do it? Can you see that story number 2 now is somehow hidden? You cannot even pick the... Okay. You shouldn't be able, but anyhow you cannot see them. Can you see? I cannot pass through them. Okay, now what I want to do, I want to select the beams which are available. Why I have done that, I want to select only the beams which are available in that level, because their loading is different from the upper one. For a small project, it's easy for you to go one by one, but if it's a huge project, it's going to be complicated to search for the beams. So what we need to do, we can go for edit, select. Can we see select? Now in select, it says for you, are you selecting a node, or are you selecting a bar, or are you selecting what is the thing that you are? Node is a point, bar is a element, panel is a slab. So we are going to go for bar. Do you remember the sections? I don't remember them. There are a lot of sections we have used, 3 sections. So I don't want to select based on the section. I want to select based on the structure object. Okay, now how many options do we have? Any means everything. Bar, we don't have bar here. Beam, column, and define. For me, I want to use beam, right? So I'll just choose beam, and there is 2 arrows. Can you see the 2 arrows here? Click on it. Now how many beams have been selected here? 8. It means that they have chosen only 8 out of the total 16. Okay, and then close. So that will help you in terms of having a huge project. I'll not finish if I have a huge project selecting one by one. Okay, so the next step is going to place a loading inside these holes. So we're going here. Is it node or bar or surface? It's going to be now, it's a bar because it's a beam. So we're going to go for a bar. Is it a UDL? It's a UDL because it's a wall. Okay, now for the slab transfer to the beams, it will be transferred automatically by the software, and I'll show you where we can assure that. Okay, anyhow, go to UDL. Is it in X or Y or Z? The loading of the wall is going to come vertical once again. So that's Z. Negative Z or positive Z? Negative Z. Can you just, what you call, can you double click on Z? Can you see that the calculator is coming for you? So we said, if you remember last class, we said 3.15 is the height for 1 meter, right? And let's say 3.5 is the total. We need to remove the slab depth. We need to remove the beam depth. So let's just say the remaining is 3 meters, approximately 3 meters. Okay, we will not go and calculate for each and every beam, although the depth of the beams are varying. So you take approximate value only. So for example, we are taking a 3. So just multiply it by 3, calculate, and then click on OK. You will see that the value is going to come here. Have you seen it? Okay, but you need to make sure that it's going to be minus. Are we fine? Okay, and then can you click on add and then apply? Can you see now the loading came on beam, only on these beams? How to make sure that they are only in these beams? Can you click here? These are filter. Okay, these are filters. Now if you unclick it, it means it will show you the whole building. If you click, it will filter you to a certain level. So if we click, you can see, okay, you can see that we have two loading. There is a loading at the top as well for my case. Okay, now what has happened, I have made a mistake. I have placed the loading of the wall in the roof finish. Can you see? For me, for example, I have made a mistake by going to roof finish. It should be, this loading should be a wall. Do you agree? And this was 1.5 was for the roof finish. Now how to modify that? What we can do, we can go for loads, load table. Can you go for load table? Can you see the loads that we have put till now? Have you seen it? Have you seen it? Okay. So we have SW, that's the self weight. We have live. We have roof finish, and I have another roof finish for my case, right? Did you get the? Did you get these? Not yet. Okay. Once again, loads, load tables. Okay. Now, what you can see, okay, what you can see here, we have SW, and the loading has not been specified because the loading will be calculated according to the geometry. Okay. Now, live load, how much is the value? -2, right? For example, I have made a mistake. It was not -2, and I want to modify. I don't need to repeat it. I'll just go from here, change the value to -3, enter. Now it's 3. Okay. Have you seen that it's easy to modify whatever you have done? Okay. Now I have done a mistake. Can you see that 9.45 is the wall, not the floor finish? So I'll just go from here, change it to wall. Can you see? Are we okay? Now, if you have finished, do not click on the top X, click on the bottom X. So you will return back. Are we fine? Okay. Now, how to verify the load? Once again, do you remember these? What you call? Okay. Do you remember these? That we have 9.45 now. Okay. Can we go to the floor finish and check? Or roof finish, sorry. Can you see the roof finish is only available now at the top? And there is no wall because we changed the wall. Do you remember? It comes in. So we have finished from this one. The other thing is going to be the parapet. Okay. So once again, to avoid making that mistake once again, we are going to, from the beginning, we are going to choose parapet. Is there any loading in the parapet? No loading in the parapet. Okay. We'll just go and specify the load of the parapet. Bar once again. Now, if you do, okay, before going here, if I go and select all the beams, what will happen? The loading will be kept for all the beams in all levels. And we don't want that to happen because we already have put the loading for the ground beams, right? So once again, the best thing, you have two options, either one by one or you filter them as I have done. So once again, we'll go for filter. Now I want story 1 or story 2. Story 2. Now you can see that the story 2 has been specified. Edit, after edit, select. Now what do I need, a node or a bar? Bar. When I say bar, it means beams and columns. Okay, so bars. I don't want the section because I don't remember the section, so I'll go for structure object, and then it's going to be as B. Now you can see that also 8 out of 16 have been specified. Are we okay? So close. We will go for definition of loading. We will go for the bar. Keep the loading. Now instead of 9.45, we are going to keep it as 3.15 because it's 1 meter or 1.2 meter depending on the company. I think you are using 1.2. 1. Some of the consultancies are using 1.2, some of them are using 1. Okay, 5 blocks or 6 blocks at the bottom. Okay, anyhow, click on add, apply. Okay, now we have finished. After you finish, remove the filtration. So have you understood why this is important for me? It's important. Why do you remember when we have done the what you call the specification of the levels last class? This will help you a lot in terms of selection. Okay? If you didn't do them, you cannot select. Okay. Anyhow, we finished from here. We have different loads. Okay, we have different loads. After that, what we can do is going to be we can do live, we can do wind and seismic, although that I prefer to do it next class, so you'll not have a lot of things. Now what we need to do after we do the loading is the load combination. Means what factor of safety will go with which loading. Okay, so what we need to do, we'll go for loading, load, and there is something called automatic combination. Have you seen? Click on it. Which code has been given? BS8110. Okay, click on full automatic combination. Okay, so this is another advantage which is available in robot, that the combination is coming automatically for you. Click on OK. After you finish, click on calculate. Have you got any error or anything? No errors. Isolated node. What's the error? No error. Isolated. Same. This one. What does it say? What is the error? Exactly. So for example, now this is where you are going to verify whether you have known that. So for me, for example, you can see isolated. Let me come and type it each and every day. Yeah. So isolated nodes, it means isolated nodes. It means you have drawn a member, but you forgot. For each and every member, there is starting point and end point. Now, if you delete the member, if you delete the member itself without deleting the point, points will be there. Now, when you delete, you need to delete the member. I'll show you how to control that or how to solve that issue. Now, anyhow, can you see when I click on isolated node? Can you see that the nodes have been specified here? Once again, just see. Okay, I just calculated. Okay, I'll come to your issue. Okay, isolated nodes. Okay, now when I'll click on isolated node, when I click on it, you can see here nothing has been specified. When I click on isolated node, you will see 8 have been specified. Where are these 8? Okay, there are 8 points extra available. So in order for me to delete them, I cannot see them. In order for me to delete them, I'll just click on the plus sign for the nodes. Can you see here? Now, if you have no errors, it will not appear for you. Okay, so plus sign. You can see the nodes are going to be specified. Can you see that some nodes have been specified already? You just click delete in the keyboard. Even you don't need to see them. Okay. Now recalculate. delete them. Once again. Okay. Now, as long as you deleted them, okay, as long as I have deleted them, it shouldn't be any problem, even if they are shown. Anyhow, for your error, if there is any error coming to any person, you just click on the error and it will show you. Now, if overlapping, it means two beams are entering inside or two columns are entering inside each other. Okay, so can you click on the error? Can you click on that later? There are two specified, but there are four beams. That means that two beams are being thrown here, and two are being once again, there are two levels of checking. One is red, one is blue. We have seen that blue are there, right? For me, it was blue. For you, it was red. Blue are not going to affect your calculation. It's only a warning that you need to check. Right? It will affect your calculation because it's an error. Even if it's a notification from you, it's a warning, it does not have that is resolved. Now there are two ways. Yes. No. I'll show you. This is because most of the software will ensure that the connection is still there. They are not separated. People previously they were asking like, can I draw the beam from the beginning till the end, or shall I draw span to span? Both the results are the same. But the most important thing, there shouldn't be overlapping, like your case. Okay, anyhow, we just calculated. Okay, we just calculated. Even if you are having warnings, they are fine. Although if I save now, these shouldn't be coming for me. Now we have loaded everything. We have loaded everything. Next step is to see our results. Okay, so what we need to go, we need to go for, from here, we need to go for results. Can we go for results? Results. And then can we go for, can you see under results there are two or three categories. One is called diagrams, one is maps. Can you see them? Diagrams is for columns and beams. To see the bending moment shear forces for columns and beams are diagrams. For slabs we call them maps. Okay, can we go for diagrams? Are we fine? Okay, now can you check now, this is the self weight at the top. Can you put it the ULS? Can you go to ultimate limit state, which is the maximum load? Do you remember when I told you ultimate and limit state, the co-chair problem? So we always design for the maximum, which is ultimate. Okay, so you go to ULS plus. Okay, now what we want to see, for example, I want to see the bending moment. Okay, so if you want to see the bending moment, click on MY. Okay, click on MY. Can you see the bending moment symbol? Can you see the bending moment diagram? Click on MY and then apply. Have you able to see? Okay, or you can see. Okay, what you can see, can we go for, now you can see that it is still hard to see. Okay, it's still hard to see, there are no values other than that. It is somehow, what you call, not convenient. So what we need to do, can you see, this is NTM. Can you see NTM? NTM means normal torsion and moment. Okay, normal torsion and moment. Near to it, can you go to the left side of it? Can you see this will appear? Can we go to parameters? Can we go to parameters? Can we choose differentiated? So it will differentiate between negative and positive for you. And then can we go for filled? And then click apply. Can you see now somehow they are differentiated between positive and negative? And can we show labels, means values? Can we show labels? Can you see now the values? Okay, so now we have the beam values. Negative bending moment, for example, for this beam is minus 24.3, and then here the positive to be 75, and it goes on. Okay, now can you see for this particular beam, can you see that it's not fully uniform, that the bending moment is not a curve, it's going a little bit down? Why? Because there is a point load from this particular beam. This beam is acting as a secondary on the primary, so it's acting as a point load somehow. Okay, and then can we go for NTM? Can we go for FZ, which is shear force? Apply shear force. Now you can see it, but it's still very small, right? Can you click on normalize? FZ. FZ means shear force. Okay, click on normalize. Click on normalize to to scale the what you call the diagram. Are we okay? Okay. Now, for example, we learned how to get the bending moment and shear forces for the beams and the columns. Okay. Now, for the columns, normally we can have normally we have uniaxial, biaxial. They can be one moment in one direction, mx and my, if you remember. Okay. So there is fx first. Can you click on fx? Can you click on fx and then apply? Okay, fx and then apply. You can see that now the maximum loading available. The maximum loading available in columns is 262 for me. Okay. Okay. We have small loading only. We didn't keep a lot of loading, so that's why the column is carrying small loading. Okay. So this is whatever we call it n value or axial loading on a column. Okay. Now, if you want to have your moments, then you can have my and mz. These are representing your x and your. Can you see here? Let me take this. Okay. I'll try to go slow. Now I want to see what is the meaning of mx, what is the meaning of my for a column. For a column. Okay. Now can you see that there is something here called edit in a new window? Can you see? What is the function of this one? The function is to isolate this member from the other members. It will open this member in a separate window. So I'm just clicking on it so we can see further. Now, can you see that this column? Let me just. Okay. Can you see this column? Or before going to the column. Can you see this column is connected to two beams? Can you see this column is connected to two beams? Okay. Now, this beam is going to have bending moment. It's like we are talking about this column. Okay, this is my column. This is the beam coming from here. There is another beam coming from here. This beam is going to have a moment. This beam is going to have another moment. So there will be two moments. One is from this beam, another one from that beam. And this is what can be shown here. Now, if I go for my, I'll see the first moment in this direction. You can see this beam is pushing my column, so it came in this direction. The other direction is here. This beam is pushing my column in the other direction. Now, if you want both of them, then these are the two. One is here, the other one is in the other direction. And if you are designing your member using Excel or Brocon or TEDS and whatever, you require the loading, which is fx, and you require these two moments. Are we okay? Okay. So once again, fx is going to give you the loading in the column. Fz is going to give you the shear force for the beams. My will give you the bending moment, the major bending moment, whatever we call major bending moment for the beams. Mz is going to give you the other direction of the minor bending moment. Okay. So this is related to the analysis. Okay. Huh? Yeah, fx is for loading. Fx is loading, axial load, or whatever we call it n. Axial load in a column is fx. Fz is the shear force on beams. My is a major bending moment, and normally it happens in beams. For column bending moments, it's my and mz. Are we okay? Now, if I want to, do you remember when we said we normally design our foundation in Excel and Brocon and TEDS and whatever? So finding these values are not a big issue. Okay, finding these values are not a big issue because actually we are going to use the software to design them for me. But I need to get the values of the foundation. Okay, because we might be using other software to design. So for the foundation, when you finish, by the way, when you finish from any of the values, you remove the ticks, because if you have a lot of ticks, it's going to be hard for you to see. And then click on apply. Now can we go here and see a reaction? Can you see the reaction? Can you see the reaction over there? Can you click on the reaction? Can you click on the reaction? Okay. And can you click on all? Can you click on all the values and then click on apply? Now you will see that your reaction, your foundation has shown some things. Can you see a vertical load, a moment? Can you see? Now there are no values, so click on description. There is description. Can you see descriptions? Click on it and then apply. Now can you see that you have the values with you? How much is a horizontal force? How much is a horizontal force in the other direction, x and y? How much is your fz? Fz is how much? 262. So this foundation is going to be designed for 262. Okay. Moments you have 11, 7. So these are the values we require: 262, 11, and then 7. Next class I'm going to show you how to design them, or how to take these particular loading or these particular parameters in Excel or Roku or whatever and design our foundation. But we are going to learn how to design the foundation as well in Roku. Okay. Now after we finish, I showed you till now, I showed you how to get the the shear forces, the bending moments of beams and columns mainly. Let's just say, okay, slabs we didn't touch them. We'll touch them next class, so it's not going to be too much. Whatever we had in the last class, the information is less than half whatever we had today. Today is a little bit intensive. Okay, but anyhow, the main thing is beam and column for the meantime. Next class we are going to tackle slabs and foundations. Now can we go for structure model and then geometry? Structure model and then geometry. Okay. Now see, because I didn't remove the ticks, these are going to disturb me, right? Okay, so once again go to geometry, results, diagrams, reaction, go to none, and then apply. Are we clear? So always it's better for you not to forget the ticks, otherwise it will disturb you. Are we okay? Okay. Now before finishing today's session, I want to see one beam with its design, and I want to see a column with its design. Okay. Now, first thing, today we are going to learn how to specify or how to take one column, one beam. Next class, we'll see how to make sure that everything is safe. Okay. Can we pick one of the beams? Can I pick? If you cannot if you cannot see them, go for section shape. In section shape, it's easier for you to choose the beams. Okay, so I'm going to choose this one, for example, or let us say this one. I'm going to choose this one. You can choose anyone. Okay, you can choose anyone. Okay, now I want to go for the design. There are two ways. Now can you tell me what is for you, for your PC, your Windows, what you call last thing that you can see here in this provided reinforcements, right? Now for me, because it's zoomed, the icons at the bottom cannot be seen. Okay, so this is where you can design. That's number one. Or you can go in design and then provide a reinforcement. Both of them are the same. They have kept for you the icon. If you can see, the icon is the same, so you can find it there, or you can get it from here. Okay, so I'm going to go for provided reinforcements for RCLM. It says for you, do you want it to be these loadings? These are the loadings that we have taken into account, right? AC, live, whatever. Click on OK. Now if you are have you got it in this way or other way? You are seeing your elements, right? Now for me, because it's zoomed, it appears like this. So if it appears like this, pull this one, bring it here. Are we fine? Okay, I'm going to what you call lower this one. Now can you see that this is my beam now? And can you see that there is something at the middle which is representing your secondary beam? Now what you need to do, can we calculate? What does it say for you? Have you got any error? Anything? Okay. You? Uh, Sir, have you got any error? Okay. Now, why I'm getting this one? Do you remember when I told you about the hook thing? Do you remember when I told you we try to connect between element and element, the length is not sufficient. We need to have a hook. Did I explain this one? Okay, so in this scenario, this is what it says for you, that you need to provide proper anchorage. So what I'm going to do, I'm going to click on the reinforcement button. In the reinforcement button, there is something called anchorage. Have you seen it? Now, it says consider hook length and anchorage. It means instead of putting the bars to be straight, I'm going to put it as a hook. Click, OK, OK, and then calculate. Now you can see that the problem has disappeared, right? Now, so one issue, I think I showed you three issues previously. One is the deflection, how to control it, how to solve it. We said we'll increase the section, and then we said the fire problem. Okay, and then we said the third one is hook. Now, can we go for beam reinforcement directly? Can we go for the beam reinforcement? Can you see your reinforcement? You cannot see. Can you zoom in, zoom all over there? No reinforcement. No reinforcement at all. Now you have at the bottom, you have main top, main bottom. Do not change it. Just click. Once again, do not change what you call. Do not go and click here because these are specified already by the software. Okay, what you want to see, click on here. We can see that we have main top here because we have negative bending moments, right? This beam is connected to something else. This beam either connected to something else, to another beam, or it's connected to a column. There must be a moment between them. Okay. Main top and the other side, it's here. Main bottom, this is my main bottom. Assembly top, that's a hanger bar. Whenever there is no top, main top, we are having hanger bar. Transverse main is the link. If we want to see it in 3D, we can click here. Can you see the 3D? How it looks like? How many bars do we have? For example, for my case, I have 3 bars, right? For you, you might be having more depending on the diameter that you have chosen. Now, can you see when you zoom in? Can you see that this bar in my picture? Can you see that this bar is bigger than this bar? This is main bar. This is whatever we call it as hanger bar, right? Hanger bar are going to be small. So this is going to be the design of beam. Now, if I want to have this one as a drawing, can we click? Can we click on calculate once again and tick generate drawing for calculated elements, and then click on calculate? Have you got anything? Some of you will get, some of you will not get. Okay. By default, you will be getting, but if the students are playing, okay, if they play, because see, you can move this one. Okay, if you move it, then you'll have an issue in return it back. But how to return it back? You will go. Can you go with me? Can we go for analysis and then drawing parameters, so you will know if you have any element later on when you use what you call software and play a lot, so you know from where to recover it back. Okay. Can we go for analysis and then drawing parameters? Yeah. Huh? Okay. I forgot that you are inside the drawing. Okay, so can we go for drawing parameters? Now, can you see in your case that you have a template? For me, I don't have a template. That's the issue. Now, for you, the template has been specified. Mine is not specified. Now can we go for the template? Can we click on the three dots? Now can you see that there are a lot of names? We have BM, ACI, BM, ACI, BM, BAE, and whatever. First two letters are representing your element. BM is representing B. ACI is representing American code. Now, which code we are using? BS code. So we should be looking for BM BS because this is the beam that we are trying to detail, and then BS. So go for BM BS. Can you see now this is BM BS? Can you see that it's BM BS? Beam and then BS. The same for the column. If the column template is not appearing, then we need to search for CL, which is representing column. CL is representing column, right? And then BS. So CL BS. CL BS. Stop. So CLBS for the column, and then we have other things like, for example, for a foundation, we have spread footing. So you need to go and use CFBS as well. Okay, CFBS. That's only if it's not appearing. If it's appearing, then it's okay. Now for my case, it's a beam. Okay, so I'm going to, by default, it will always appear unless you start playing. BMBS. Now when I open it, click on OK and then calculate. You will see that it will appear with me. You will see that it will appear for me. Now we can see that this has given you the length of the element. This has given you the cross section. Other cross section by taking 1 2 seconds and 2 of them. And then the shape of the reinforcement for your doing sorry. Now this can be taken to this can be taken to a cap rather than trying to do the details. So we can go to file. Okay, we can go file and then save drawing in a different format, and you can save it as DXF, which is still wait, maybe we take something else. So DXF, I'll just show you. Okay, so I'm just saving it. So now I need to search for this DXF. Now you will see whatever drawing has been generated by the software, it will come automatically as CAD drawing. And we'll see a column. Okay, we'll see a column, tentative column. This Procon will kill me. Uh, can you see now this is coming for you? Okay. This is for a beam. You can do the same thing for a column. Can we go for a column? So returning back from here. choose one column. The same process, designing, provided reinforcement for RC element. Okay. Your column will be coming. This is the cross section of the column, which is 200 into 500. It will show you how much is the total height. It will show you how much is your beam depth. It will show you how much is your slab depth. Do you remember this thing? 1.12.55. So everything has been shown. We will go for calculate. This is going to be my column. Stuck? Stuck? Okay. So this is going to be your column reinforcement. This is going to be your column reinforcement, and you can see there some kind of heavy reinforcement near to the bottom, and you can see that this is the 3D. How many bars are there? That we have 6 bars. Okay, 6 main bars of 12 diameter, and then we have stirrups. Okay. And the same thing that you can do: calculate, generate drawing for calculated elements. It does not appear once again. So if it does not appear, analysis, drawing parameter, we said it's now CLBS. For you it will appear. Okay. CLBS. Okay, so you can see that the cross section is appearing with the longitudinal reinforcement. Doing that will stop today. So what I want you to do, I send you the video, but you put it with sentences. Go and do whatever, try to play with the loading according to the, I send for you the government. So according to the loading, you want to play in that part, okay? And then try to see different columns. So one column from inside, one column from outside, small beam, long beam, and cross section, and see what are the errors you want to be shown, what are the things to be taken into account. And then next class we're going to do is that foundation and the exercise. You can see that if we go 4 hours, then already it will be too much for you. So from now on, till we finish, we'll have like 2 hours, 2 hours, and then you need to practice. So now, for the meantime, that file that you have put in your folder, okay, you work on it from the beginning, whatever we have done. Okay, not from the modeling. We have finished the modeling. So start whatever we have applied to it, from applying load and everything, checking, rotating, start playing with the things. If you have any doubt, let me know. Okay. And then after you finish and you are confident for whatever we have finished, the beam reinforcement, the column reinforcement, the errors, the rotation, whatever, we will go for the next class. And I'll send for you, I told you, but remind me, I'll send for you the video of how to shift the columns using different methods. Okay. But once again, just check with your boss regarding the what you call it, the civil engineering. في ما متواصل معاه civil engineer اليمني ولا من بعد؟ قولي زين قولي ارسل لي sample. Okay. Sample and see. Because I'm assuming he is doing the practical case which is in the center. Now what happens? In reality, beams are going to be straight. Beams are going to be straight, but for you are trying to have the total concentrated load at the center. Okay. Just see, in case he is doing like that, I wouldn't prefer you to change from whatever he is doing. Okay. For the whole thing, this is what I said for you. For live load, we have a code. The code specify, for example, if you are having a mosque, then this is a typical load. If you are using, for example, restaurant, then this is the loop. It varies. Okay, let me show you. Okay, so this is one of the codes that we normally use. Zooming is going to kill me. So this is called weights of building material. So according to the finishes that you're having, each and every finish, it has its own weight. So for example, if you are doing aggregate, then this is the typical weight of the aggregate. For example, if you are doing limestone, limestone tiles, for example, or stonework, it has this amount of weight. So as per whatever specification you have put for that particular project, it varies. Okay. Some of the consultancies are having fixed value, so they calculate it and they will use that value. But once again, it depends on the specification. I don't want to say for you, and I'll give you that sample. We used to use it, but once again, that varies depending on. And مثلا somebody who's using granite, let us check granite. So for example, granite, it depends if it's like 50 mm thick, 75 mm thick, the weight will vary. So for example, here the loading is 130 kg per meter square. Here it's around 200. Okay, because of 25 mm difference between them. Okay. Now, if you go, for example, for terrazzo, terrazzo is not available. Okay, or let us go for tiles. So terrazzo here. Okay, so you can see terrazzo is like for tiles is around 48.8 plus minus 4.9. Okay, so we can say it's around 52 around. Okay, but when we have checked granite, granite reached to almost 200, right? So that will vary depending on the requirement of the client himself. And I'll not put granite, for example, at the roof, right? Yeah, but there are common things, and there are, like I told you, yeah, based on based on function. يعني مثلا لما أنا um, let us say at the roof, there is no point of me putting granite. So in the specification of roof, for example, I'll use terrazzo. Terrazzo only were the old ones with colors. So depending on the regular specification used by your consultancy, you will use it. Yeah, for example, if it's a play area, it's not recommended for me to put what you call, if it's for example billiardo or billiards or like say bowling and whatever, it's not recommended to put tiles. We normally put like wood. So wood is going to be a little bit different depending on the specification, the common specification. Okay, and always you'll be taking somewhere higher, somewhere higher, but depending on the specification. Normally, as I told you, for each and every consultancy, they are having their own. When you go for your roofing, or if you open the architectural what you call section, you will see they have specified for your consultancy what are the things to be. And I'll attach for you. I'll try to point it out. But other thing that you can do, you can refer to that structural engineer in your consultancy. He will be using a certain value based on whatever he has calculated. But I don't want to give you a value and then it will come something different than whatever you have used. I'll give you a sample from whatever we have done in our consultancy. We check what they are using, so at least you have a common point where to judge. Now related to live load, we have 6399. I'll send for you these codes. I'll upload them in the what you call. I'll upload them in the drive. Now see here, the code says for you if it's domestic and residential activities, it is 1.5. If you are talking about, for example, bedrooms in hotels and motels, normally more furniture is there, so it's like 2. If it's a kitchen and it's common, then it's going to be 3, and it goes on. But here in Oman, we don't have separate live loads normally. What we have done, we don't use separate live loads for the different functions of rooms. We take only one for the whole flow. Okay, which is normally the higher side. You check whatever are the function, take the higher side. As I told you, it might be a room, he might be shifting it to be a store because nobody is there now. So you need to take into account, because bedroom or a room is going to have less load compared to a store. So I should be designing it for something higher. So all of them for the higher side. Okay, one value. This is what we normally do. So I'll upload this one. I'll upload for you structural calculation that we have done. Loading is there, and you can see the values and everything. Okay. So you can, as I told you, you can go through whatever we have done. I'll upload for you the video um, with the structural calculation with the codes, and you can try checking